Hey, it's Tony the Triangle Teletubby talking to you about isosceles triangles and equilateral triangles. Hey, we're in New York City eating pizza talking about triangles, eating Big Apples. That's why they call it the Big Apple.
First thing we're going to talk about is an isosceles triangle. That's a triangle with at least two congruent sides. So if we look at our diagram down here of an isosceles triangle, you can see that the two congruent sides we denote with these little tick marks. Those are called the legs. The base is the non-congruent side. And then the two angles that are formed by the base and one of the legs, base and the other leg, those are considered your base angles. They are opposite the congruent legs. The vertex is going to be the angle at the top. That's your vertex angle. Now, please note that it says an isosceles triangle is a triangle with at least two congruent sides, meaning that it could have three congruent sides, meaning that an equilateral triangle, a triangle that we're going to talk about in a second, where all three sides are congruent, would be considered technically an isosceles triangle as well, because it has at least two congruent sides. Now, our equilateral triangle, the thing we just talked about, is a triangle with three congruent sides. So down here, we have a triangle. We know that all three sides are congruent. That's what these little tick marks mean. And you can see that because all three sides are congruent in our triangle, all three angles are also congruent. So an equilateral triangle is technically also an equiangular triangle. Remember, equa means equal or same. Lateral refers to sides. Equiangular means equal angles. So an equilateral triangle, we said just now, is both equilateral and equiangular. The isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. In our isosceles triangle right here, we just said our base angles are the angles that are formed by the base and one of the legs. The base and one of the legs. So those base angles are actually going to be congruent in an isosceles triangle. And it makes sense, right? Because the sides opposite them are also congruent. So in this figure, if I know segment AC is congruent to segment BC, then I know those angles that are opposite those sides, angle 1 and angle 2, must also be congruent. That's the isosceles triangle theorem. The converse of the isosceles triangle theorem says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So now this is saying if you don't know anything about the sides, but you do know two of the angles in a triangle are congruent, then you know that the sides that are opposite those angles must be congruent. So if I know angle 1 is congruent to angle 2, I know that segment AC must be congruent to segment BC because those sides are opposite the congruent angles. Now let's talk about the equilateral triangle corollaries. The first one says a triangle is equilateral if and only if it is equiangular. So whenever you see a statement that says if and only if, that means that it works both ways. So a triangle is equilateral if and only if it is equiangular. So that's saying that a triangle, in order to be equilateral, in order for all three sides to be congruent, all three angles must be congruent. And since it's an if and only if statement, it works the other way as well. If you want a triangle to be equiangular, you know all three sides must be congruent. So all three sides have to be congruent in order for a triangle to be equiangular as well. Again, in order for a triangle to be equilateral, it must be equiangular. In order for a triangle to be equiangular, it must be equilateral. The second equilateral triangle corollary says each angle of an equilateral triangle measures 60 degrees. And that makes sense, right? Because we just said in order for a triangle to be equilateral, it must be equiangular, meaning that all three angles must be congruent. And if all three angles add up to 180 degrees by the triangle angle sum theorem, then you just take 180 divided by 3, and each of them must be 60 degrees.
Hey, Jeter, DiMaggio, Babe Ruth, Yankees, example time.
Example 1 says find each measure. So we're finding the measure of segment EG. Where is segment EG? That's right here. Okay, so in order to find the measure of segment EG, I clearly need to find X. So that's going to be my first step. So how do I find X? Well, I need to set up an equation. So what do I have here? Well, it looks like in this triangle, I know that angle F and angle E are congruent. They have the same measure. Therefore, because I have two congruent angles, I know that the sides opposite them must also be congruent by the converse of the isosceles triangle theorem. So I could say that since angle F and angle E are congruent, segment FG must be congruent to segment EG. And if I know that they're congruent, I know their measures are equal, so then I can substitute in the measure of segment EG, which we know is 9x minus 15, and that goes in here. I can substitute 4x plus 9 in for the measure of segment FG right here. Now all I have to do to find x is just solve this equation for x. So let's do that. First, I'm going to subtract 4x from both sides. I'm going to add 15 to both sides, and then I'm going to divide both sides by 5. And I get x is equal to 4.8, or 24 over 5. Remember, don't round too early, but in this case, you didn't really have to round. This is the exact answer. So I found x, but that's not what the question's asking. It's asking to find the measure of segment EG. What's the measure of segment EG? That is 9x minus 15. So I take what I just found x to be, 4.8, plug that in for x here, and I simplify. What's 9 times 4.8? That's going to be 43.2. I then subtract 15, and I get the measure of segment EG is 28.2 inches. Remember to write your units if you're given units. Part B says find the measure of angle S. Okay, so where's angle S? That's here. Oh, they don't give you anything. But they do give you that all three sides are congruent. And remember, in order for a triangle to be equilateral, it must be equiangular by the equilateral triangle corollaries. So I could then say, since all three sides are congruent, that all three angles are congruent. So I know that each of these angles must also be equal to x plus 9. Now, to find the measure of angle S, I clearly need to find x again. So let's find x first. How do we find x? Well, I know that all three of these angles must add up to 180 degrees. Or, by the equilateral triangle corollaries, I know that this is an equilateral triangle, meaning that the measure of each angle in here must be 60 degrees. So I can take the measure of angle S and set that equal to 60 degrees. Now, in order to find x, all I have to do is take what the measure of angle S is equal to, x plus 9, plug that in here. So to solve for x, I subtract 9 on both sides. I get x is equal to 51. Now, in order to find the measure of angle S, all I have to do is just take what I know the measure of angle S is equal to, x plus 9, and plug in what I found for x, 51. I get 51 plus 9, which is 60. So the measure of angle S is 60 degrees. Oh, wait, we already knew that. This is an equilateral triangle, and by the equilateral triangle corollaries, we know that the measure of each angle must be 60 degrees. So I technically didn't even need to solve for x. I just had to figure out that this is an equilateral triangle, therefore the measure of angle S is 60 degrees.
Hey, greatest city in the world, New York City! Time for you to try.
Okay, for part A, we're finding the measure of angle E. So where's angle E? That's right here. Okay, interesting. Well, how do I do this? Well, in order to find the measure of angle E, I clearly need to figure out what is x. So I need to set up an equation. Well, I know that the measure of segment GF is equal to the measure of segment GE. So by the isosceles triangle theorem, since I know this is an isosceles triangle, these are congruent, that the base angles are congruent. So these two, angle F and angle E, must be our base angles because they're opposite the congruent sides. So if these are congruent, then I can set their measures equal to each other, right? The measure of angle F must equal the measure of angle E. So then I substitute in what I know those are equal to. The measure of angle E is 4x minus 2. That goes in here. The measure of angle F is x plus 27. That goes in here. I then solve for x by subtracting x on both sides, adding 2 to both sides, and then dividing both sides by 3. And I get x is equal to 9.6 repeating, or 29 thirds. I then need to find the measure of angle E. So the measure of angle E we know is 4x minus 2. I just found x. It's 29 thirds. So I take 29 thirds, plug it in for x here, and I simplify to get the measure of angle E. Well, how do I multiply these two together? Well, 4 is the same as 4 over 1. So to multiply fractions, you multiply the numerators together and denominators together. So 4 times 29 is going to give you 116. 1 times 3 is 3. Now I need to subtract these two. How do I subtract these two? Well, to subtract fractions, you have to have a common denominator. So 2 over 1, I multiply the numerator and denominator by 3, and I get 6 over 3. So what's 116 over 3 minus 6 over 3? That's 110 over 3. So I would let you leave your answer like this, or if you want to get a whole number degree, I would let you write it as 36 2/3 degrees. Part B, we are finding y and the measure of angle r. So how do I find the measure of angle r? Well, there's nothing here. Okay, well, I know that this is a triangle, and I know that these two sides are congruent. So that would make this an isosceles triangle. And by the isosceles triangle theorem, if the two sides are congruent, the two base angles must also be congruent. Those would be the angles that are opposite the congruent sides. So angle r and angle s must be congruent. So if the measure of angle s is 2y plus 19, the measure of angle r must also be 2y plus 19. Perfect. Now what do? Well, I first need to find y. So let's find y. I need to set up an equation to find y. How do I do that? Well, I know that this is a triangle, therefore all of the angles must add together to equal 180. So I could say that the measure of angle Q plus the measure of angle R plus the measure of angle S has to equal 180 degrees. Now I can substitute what I know those things are equal to. The measure of angle Q is 80 degrees, that goes in here. The measure of angle R is 2y plus 19, that goes in here. And the measure of angle S is also 2y plus 19 because it's a isosceles triangle. And by the isosceles triangle theorem, if the two sides are congruent, the two base angles must be congruent. So I plug those into their respective spots, and now I can solve for y. So let's combine like terms. 80 plus 19 is going to give you 118, and then 2y plus 2y gives you 4y. I can then solve for y by subtracting 118 from both sides and dividing both sides by 4. I get y is equal to 15.5. Next, I need to find the measure of angle R. So we know the measure of angle R is 2y plus 19. So I take what I just found y equal to, I plug it in over here for y, and I simplify. What's 2 times 15.5? That's going to give you 31. We then add that to 19, and we get the measure of angle R is 50 degrees. Now, example 2 says find the measure of the given variable. So here our variable looks like it's z, so we need to find z. Well, how do we find z? How do we set up an equation here? I guess we could just say that the measure of angle Q plus the measure of angle R plus the measure of angle S has to equal 180 degrees by the triangle angle sum theorem. Well, the question then is, what is the measure of angle R? Well, since I know this is an isosceles triangle because these two sides are congruent, then I know the base angles must be congruent by the isosceles triangle theorem. So if the measure of angle S is 2z minus 5, then the measure of angle R must also be 2z minus 5 because those are the base angles. They're the angles that are opposite the congruent sides. So then I can take what each of these angle measures are equal to and plug them in up here in that equation that I just set up. So z squared minus 62, I plug in for the measure of angle Q. 2z minus 5, I plug in for the measure of angle R and for the measure of angle S. Now I can solve for z. So let's simplify. Here, we're going to combine like terms. Z squared plus 2z. Oh, this is a z squared. This is a z to the first. Those are not like terms, so I can't combine those. I can add the 2z and the 2z and get 4z, and then negative 62 minus 5 gives me negative 72. Now I get something that looks like this. How in the world am I supposed to solve for z? Well, if you recall, anytime you have a z squared and a z to the first, or an x squared and an x to the first, I need to get everything to one side of the equation and set it equal to 0. So what I'm going to do is I'm going to subtract 180 from both sides, and negative 72 minus 180 makes it more negative. It's going to make it negative 252. Now you see I have a quadratic trinomial. Quadratic just means it's degree 2, and it's a trinomial. It's got 3 terms. And this quadratic trinomial is set equal to 0. To solve this, to get what z is equal to, I need to factor it into 2 sets of parentheses. So in order to do that, there's a couple different ways you can do it. You could use the quadratic formula. You could do factor by grouping. Here, I'm going to use the magic x. The magic x works by putting the a value times the c value on top. So what is our a value? The number in front of z squared, that's 1. Our c value here is negative 252. So 1 times negative 252 is negative 252. Our b value, positive 4, the number in front of z to the first, that's going to go on the bottom. We then have to think about 2 numbers who multiply together to make negative 252. Their product is negative 252. Their sum, when I add them together, has to be positive 4. So what are 2 numbers that multiply together to make negative 252 and add together to make positive 4? Those numbers are negative 14 and positive 18. I then divide each of those by my a value, which in this case is 1, so it's not really doing anything. And I'm going to write my parentheses going bottoms up. So the bottom number goes with my z, so it's going to be 1z minus 14 in the first set of parentheses. In the other set of parentheses, it's going to be 1z plus 18. Now again, this is set equal to 0. So I can now solve this by using the 0 product property. If I know 2 things multiplied together equal 0, I just set each of those things equal to 0 and solve for z. So the first one, I add 14 to both sides and I get z is equal to 14. The second one, I subtract 18 from both sides and I get z is equal to negative 18. So I have 2 answers, 14 and negative 18. Now, you need to check both of your answers because there might be one that doesn't work. If I plug in 14, 28 minus 5, okay, that makes sense. 28 minus 5, okay, that makes sense. 14 squared minus 62, okay, that still works. What about if I plug in negative 18? If I plug in negative 18 for z, 2 times negative 18 is negative 36. Minus 5 gives me negative 41 degrees as my angle. That doesn't make any sense. So z equals negative 18, that is not one of my answers. That does not work. So I cross that out, and my only answer that I'm going to put is z is equal to positive 14. Because when z is equal to negative 18, it gives me negative angle measures, which can't work. They have to be positive.
Hey, I'm not trying, you try it.
Okay, doing the same thing here. I'm finding the measure of the given variable here. That's going to be x. So how do I find x? Well, again, I have a triangle, so I can just add up the measures of each angle and set that equal to 180 degrees. I know the measure of angle A, I know the measure of angle B, but I don't know the measure of angle C. I do know that segment AB is congruent to segment AC, which makes this an isosceles triangle. So by the isosceles triangle theorem, the base angles, the two angles that are opposite the congruent sides, must be congruent. So angle B must be congruent to angle C. So the measure of angle B is 3x minus 5, meaning that the measure of angle C must also be 3x minus 5. So now I can plug those in for what they're equal to up here in our equation. X squared plus 30 goes in for the measure of angle A, 3x minus 5 goes in for the measure of angle B, and the measure of angle C. Now I need to solve for x, so I combine like terms. X squared, there are no other x squareds, so I can't combine that with anything. The 30, I can subtract 5 and subtract 5, and I get 20, and then 3x plus 3x gives me 6x. Again, I have an x squared and an x to the first. So I need to get everything to one side. So I'm going to subtract 180 from both sides. 20 minus 180 is going to give you negative 160. And now I have a quadratic trinomial. Quadratic just means it's degree 2, and it's a trinomial. It's got 3 terms. And because it's set equal to 0, I can factor this and solve for x. How do I factor this? Again, there's a bunch of different ways to factor this, but what I'm doing is the magic x. In the magic x, I take my a value times my c value. So 1 times negative 160, and I put that on top. My b value, positive 6, goes on the bottom. I then think about two numbers that multiply together to make negative 160 and add together to make negative 6. So those two numbers that multiply together to make negative 160 and add together to make positive 6 would be negative 10 and positive 16. I then divide each of those by my a value, which again is 1, so it doesn't really affect it, but it helps me see how I'm going to put it in parentheses. When I put it in parentheses, I go bottoms up. The number at the bottom of our fraction is going to go in front of the x. So it's going to be 1x minus 10 times 1x plus 16. I then remember that that's set equal to 0, so I can solve for x using the zero product property, which just says if you have two things multiplied together that equal 0, then either this equals 0 or this equals 0. So I set each of them equal to 0. X minus 10 equals 0, x plus 16 equals 0, and solve both of those for x. So here, to solve this for x, I add 10 to both sides, and I get x is equal to 10. Here, if I subtract 16 on both sides, I get x is equal to negative 16. Now I need to make sure that both of those answers worked. So when I plug in 10, 30 minus 5, that's 25. Okay, 30 minus 5, that's 25. Yep, and then 10, that's 100, plus 30, 130. Okay, that makes sense. What if I plug in negative 16? 3 times negative 16 minus 5, oh, that's going to be a negative angle measure. So anything that gives me a negative angle measure is not going to be one of my answers. So my only answer here is going to be x is equal to 10. Now, example 3 says, given segment CE bisects angle BED and triangle BED is isosceles, we're going to prove that triangle ECB is congruent to triangle ECD. So the first step in a geometric proof is to mark up the figure with the given information. So what are we given? We're given that segment CE bisects angle BED. Now, it doesn't say anything is congruent yet, so we can't mark anything up, but this will come in handy when we start game planning. Here, triangle BED is isosceles. Again, this doesn't say anything is congruent, but it will come into handy when we start game planning on how we're going to prove this. So we move on to step 2, which is to state our given in our proof. We are given that segment CE bisects angle BED and triangle BED is isosceles. The reason for that, it's given. Step 3 in a geometric proof is to come up with a game plan. How do we get from our given to what we're trying to prove? Well, again, we are given that segment CE bisects angle BED and that triangle BED is isosceles. And we're trying to prove that these two smaller triangles are congruent. Well, if I know that segment CE bisects angle BED, remember bisect, bi means two, sect means cut. So if segment CE bisects angle BED, that just means it cuts it into two congruent angles, meaning that angle BEC is going to be congruent to angle DEC by the definition of angle bisector. We also know that triangle BED, the whole big triangle, is isosceles, meaning that these two sides, segment BE and segment DE, are going to be congruent to each other. And that's just the definition of isosceles triangle. We also know that if you have an isosceles triangle, the two angles that are opposite those congruent sides, the base angles, must be congruent by the isosceles triangle theorem. Lastly, we know that these two triangles share a side, so we always mark that up. Segment CE is congruent to segment CE by the reflexive property. So now, we're trying to prove these two triangles congruent. There's a couple different options. You could go angle, side, angle, angle, side, angle. You could go angle, angle, side, angle, angle, side, or like I'm about to do, we're going to go side, angle, side, side, angle, side. So here's how I'm going to do this. I'm going to do side, angle, side. First, because triangle BED, the whole thing is isosceles, I know that segment BE must be congruent to segment DE. And the reason for that, that's just the definition of an isosceles triangle. If it's an isosceles triangle, then it has at least two congruent sides. Next, what I can do is say, since I want to prove that these two triangles are congruent by side, angle, side, I need another side. So I'm going to say that segment CE is congruent to segment CE by the reflexive property. Last but not least, since segment CE bisects angle BED, then I know that these two smaller angles must be congruent by the definition of angle bisector. I now have shown that this side is congruent to this side is congruent to this side, and the included angle, the angle that's between the two corresponding congruent sides, those two included angles are congruent. Therefore, these two triangles then must be congruent by side, angle, side congruence postulate. Again, several different ways to do this. Even within this one proof, I could have mixed up steps 2, 3, and 4. It doesn't matter what order those go in. Just make sure you have the right corresponding reasons over here.
Hey, where are all my tinky winkies? You try.
Okay, doing the same thing, geometric proof. First step in a geometric proof is to mark up the figure with the given information. So what are we given? We're given angle HKJ is congruent to angle HLM, so we mark that up here. We then are given that triangle JHM is isosceles, so the whole triangle is isosceles. We're not going to mark that up yet because it doesn't say anything is congruent. That'll come in handy later on when we're doing our game plan. Next, step 2 in a geometric proof, we need to state our given. So we're given angle HKJ is congruent to angle HLM, and triangle JHM is isosceles. The reason for that, it's given. Step 3 in a geometric proof, come up with a game plan. How do we get from what we're given to what we're trying to prove? Well, based on this figure, again, we already have marked up these two angles. That was part of our given. We're also given that triangle JHM is isosceles. Remember, because it's isosceles, you know that it has at least two congruent sides by the definition of isosceles triangle. And it looks like segment JH and segment HM are the two congruent sides. So we can say those are congruent by the definition of isosceles triangle. You also know by the isosceles triangle theorem that the base angles of an isosceles triangle, the angles that are opposite the congruent sides, must also be congruent. So we can mark that up. Now again, what are we trying to prove? We're trying to prove that angle JHK, this little angle right here, is congruent to angle MHL, this little angle right here. Well, how do we prove that? Well, based on what we've marked up, we can actually show that this little triangle over here is congruent to this little triangle over here by angle, angle, side. Because we have two angles congruent to two angles, and the non-included side congruent to the non-included side. Therefore, they would be congruent by angle, angle, side congruence postulate. We then can say that since these two triangles are congruent, that their corresponding parts must be congruent. So these two angles would be congruent by CPCTC. So that's how we're going to do it. So again, we have shown already that these two angles are congruent. We need to next show that this side is congruent to this side. So we say that segment JH is congruent to segment MH by the definition of isosceles triangle. Because it's an isosceles triangle, it must have at least two congruent sides. We then say, because it's an isosceles triangle, that the two base angles must be congruent. Angle HJK and angle HML, or angle J and angle M, if you want to refer to it that way. Those are congruent by the isosceles triangle theorem, which we stated earlier. Next, because we have shown that two angles and the non-included side of one triangle are congruent to two angles and the non-included side of the other, those two triangles are congruent by the angle, angle, side congruence postulate. And because these two triangles then are congruent, their corresponding parts must be congruent. So this angle right here must be congruent to this angle right here by CPCTC.